Hello students, I hope you're doing well. Today I wanted to talk to you about Lab 11, which is parallel circuits. We're looking at resistor and inductors together, so just a parallel RLR circuit is what we're going to look at. So we're building this circuit. We have a 120 millihenry inductor in parallel with a 2.2 k ohm resistor. The applied voltage on this, and I sort of pulled that way, the applied voltage on this is going to be 2.54 volts, and that's RMS, so we'll be using our digital meter today. We're looking at this right here, and we've got this set for 2 kilohertz. Okay, so we're looking at this, and we're measuring the voltage across our circuit here. I've got all my leads over on the other side here connected together, so I'm looking at source voltage along with the applied voltage across my components. So we're looking at that there, and we're getting right at we need to be dialing up 2.54, so let's see if I can bring that up just a little bit, pop it up just a bit, see if I've got the touch today. So that's probably about the best I'm going to get. So 3.54 is what we're shooting for, okay? And so we're looking at this, we're measuring voltage. We're just going to measure when you're measuring voltage across these components. When I'm looking at my inductor and my resistor, is I will measure voltage across here, measure voltage here, and measure voltage here. Now you realize that this is in parallel, so if I measure voltage one place, I've measured it every place. So I just measure voltage there and there, and I've got total resistance. Now, one thing we do in this circuit is we measure branch current. So we're measuring the current through the resistor and the current through the inductor. One of the techniques we use we call hike a leg and poke a wire. So we're going to lift the leg up from the component we want to read, and we place our meter in there. So I've got to do a couple of things. One of the things I have to do is set this meter up to read current. So I'm going to change this to read AC current, and see a little squiggly line, that's AC current, and I also have to move my red lead to go there. So now I'm measuring current. I'm going to pull my leads out from my meter. My power supply is still across my circuit there, as you see, and so I want to measure the current that comes out of that resistor. So what I will do is I will lift this leg up. I'll insert a wire from where I pulled it up, and then my meter goes between those two wires. So I will put one lead here on the resistor, and the other lead will go where I pulled it up from. That was my lead. Make sure they don't short out now. I want to separate them, and I'll back off so you can get a little bit better shot. So I've inserted my meter to where my lead was. There's my resistor there. It comes through this, it goes through the meter, it comes out there. And so I'm going to look at my reading for my current there, and that's 1.6 milliamps. And let's back up just a little bit. And so I disconnect my meter here, and I need to rebuild my circuit. I'll take that out there and move that, put that back to where it came from. So, and then I'm going to measure current through my other device, which is my inductor. So I'm going to measure current between these two leads here, these two wires. That's my inductor there, and that's where I pulled it at. And I'm reading, as you can see, I'm reading 2.32 milliamps. You can sort of see where I've inserted that meter where my inductor is here, between these two places. So I'm reading the branch current coming out of that inductor. And rebuild my circuit. And I want to measure current through my whole circuit, so I'm going to disconnect from one end of the power supply, insert my meter, and make sure that my inductor gets put back in that circuit there. And now I'm reading 2.98 milliamps. So that's showing how I read the current. And then, so we've looked at everything in this circuit. So let's take a look at some of these sheets here. So these should be your expected values that we're looking for. We are looking for, these are just going to be measured values right here. So we look here, this should be somewhere close to what we're looking at. You can, some meter will read this. We have a LCR meter that you can borrow and use that. This is just the ohmic value of the winding of the inductor. These are measured values that we just looked at with the inductor, resistor, and total current. These are calculated values. And then these are the values that we are looking for here. So remember, we have this new formula that we hadn't used very often, but we're figuring out the ohmic value of the inductive reactance here. And we use this formula 2 pi f of L, and we're just using sort of the measured values that I came up with, which was that 1.9. Instead of 120 millihenries, I'm using the 1.9 milliamp or millihenry, and I came up with about 1.5 k ohm. You see 1.469, very close. Then I'm using total impedance, and that's that Z. We're using Ohm's law for that. So that's going to be my voltage source divided by my total current. And I come up at 1.24 k ohms. And then I want to calculate current. So I'm using the Pythagorean theorem here, is that I'm taking the current of the resistor squared plus the current of the inductor squared. I take the square root of that, and that gives me the total current at 2.85 milliamps. And then we're looking at individual currents for the for that value. You can see it was measured at, or it was calculated at 2.36 milliamps and 1.626 milliamps. Okay, and I just use Ohm's law to get those values for those individual branch currents. So that's what you're looking at as far as experimentally what you're looking for and some of the computations you'll be needing to do. And then there's some other cognitive questions you'll need to answer. We'll talk a little more about the Pythagorean theorem and how to apply that in this class. So looking forward to seeing you in class and answering these questions. And I hope you have a great day, and I hope this is helpful.